Wonderful geometry students. I am clearly not here right now. So I have an appointment this morning, and that is why you are watching this video. Anyway, all of you should see this little packet here. This is our practice quiz. And I wanted to give you a little guide of me kind of walking through it with you because before every quiz that we will take in geometry or any math class, I like to give you a practice quiz. So what this will be is basically a carbon copy of what your quiz will be tomorrow. We're going to be quizzing over Unit 1, and that includes our measurements of line segments, of angles, solving for x with angles, and also using the midpoint formula and the distance formula. So I am going to walk you through that now. So everybody go ahead and get settled, get that little test quiz packet, the practice quiz, and you can just follow along while I guide you through it. So, first of all, this quiz is going to be worth a grand total of up to 33.5 points. So, it's about worth the same amount as 3 days worth of exit tickets. And then you have the opportunity on the last page to earn a possible 2 bonus points. And we'll talk about that once we get there. So let's get started with number 1. In question number 1, it tells us to measure the line segment in inches, and then we construct the perpendicular bisector. So whenever we are measuring inches, we are going to be using our rulers. So I'm going to grab my ruler, and we're going to zoom in really close for this part because I want you guys to be as exact as possible. So remember, when we measure with a ruler, we want the end of that line segment. Let's see if I can get this to focus. There we go. I want the end of my line segment right there to line up as perfectly as possible with that first mark on my ruler, like that. Then I want to line up the other endpoint and see where it falls on my ruler. So I'm going to make a little mark here, because I know that this is my 2 inches. I know this is 1.5. And let's see how many little lines we've got here. Got 1, 2, 3, 4, 5 from 1.5. Or I could count from 2 here and go backwards. 1, 2, and we land on the third one. So this is where I would be using the big inch paper. So I'm gonna grab that real quick. So this focuses. Pause. So here it is, the giant inch. And let's look at our measurement. So I think I'm going to count backwards from 2 inches because there are less tick marks to count here. So 2 inches and then 1, 2, 3 backwards. So here I am at my inch, and I'm just going to go 1, 2, 3 backwards. 13/16 is my fraction, it looks like. So since I pass 1 inch, that would mean that my official measurement is 1 13/16 inches, or inch. 1 13/16 of an inch. So I will circle that answer because that's my answer. I want you to circle those answers. So we did the first part of question 1. We were measuring the line segment in inches. And the second part says to construct the perpendicular bisector. So I'm going to remind myself where my endpoints are, since I did draw some little dashes and some tick marks when I was measuring. And for this part, we are going to need our compasses. So if you do not have a compass at your seat, let's pause the video and come and get one from the front of the room. And when we get back, we will begin. So here's my compass. The first place I start whenever I'm constructing a perpendicular bisector is with the pointy part of the compass on one of my end points. Now I'm going to make sure that my compass is open at least halfway through the, at least half the length of this line segment here. So I'm going to open it about there. You could also do it from endpoint to endpoint, but I don't want to go through my words. So I'm going to open it a little bit less, maybe about here. So I'll start by making my arcs. One here. Then I'm going to take my pointy part of my compass to the other end point and make another arc. So here you see we have our first intersection. Now I'm just going to do the other side, doing the same thing. Go. And now the most important thing to make sure is that your compass is opened at the same width for all 4 of these arcs here. We don't want there to be any inconsistencies, or our intersections here are not going to line up how we need them to. So we've got our arcs. We have now created 2 new intersections. And those intersections are going to tell us exactly where to draw the bisector. So I'll just take a straight edge or my ruler and line it up with those little points we made. Line through it. So there is my perpendicular bisector, but I'm not done yet. I also need you to label all of the things we just created. So first of all, when we have a perpendicular bisector, we know that this creates a perfect 90-degree angle. So to indicate that, we need to put a box right here to show that this is 90 degrees. And then, since this is a bisector, it means that we have cut this line segment into 2 equal parts, meaning that the measure of this part of my line segment is equal to or congruent to this part of the line segment. So we need to show that by putting our 2 little dash marks. So talk about requirements here. This problem, question 1, is worth 3.5 points on your quiz. And here's where those points come from. You will have half a point that comes from these little marks on your bisector. Talking about these here. This is showing me that you have cut your line in half perfectly. Then you'll get another 0.5 or another half a point for showing that you have created a 90-degree angle. So you need to draw that box. And you will get 1 whole point for having your arcs drawn properly, meaning that I see there's an intersection on top of the line and on the bottom, and that your bisector goes right through those intersections. So here are 2 points. The other 1.5 come from your measurement. So you will get plus 1 point for the correct measurement. And another half a point for remembering to say inches. We don't just say 1 13/16. We need to specify that we're talking about inches here. So I'm going to put inch. All right, there is number 1. Now let's look at number 2. So number 2 is a multiple choice question. I have given you an angle, and you are to measure this to the nearest degree. So whenever we want to measure an angle in degrees, we need to use our protractors, which you all should have at your tables. So here's my protractor. And we want to start by taking this circle, this hole in the bottom of the protractor, and we want to line it up perfectly with the vertex of our angle, right there. Then we want to make sure that the ray on the bottom is lining up nicely with the protractor here at 0. Now I just want to see about where this angle falls. So the second ray of my angle looks like it's pointing at either 50 or 130. So I need to think about whether I'm using the inner numbers or the outer numbers. And I can reason that if I am looking from here and my angle's opening this way, that means at the close of my angle, it started at 0 degrees. Then it got bigger, 10, 20, 30, 40, 50. So 50 makes more sense than 130 here. So our answer for number 2 would be C, 50 degrees. And this question is just worth 1 point. So let's flip through the next page now. For number 3 here, you are supposed to construct the angle bisector. So let's do that together. First, we need our compasses again, and we want to start with the point of our compass on the vertex of our angle. Now, let's talk about how wide I need my compass to be opened. If I open my compass too big, then my intersection that I'll be creating with my arcs is going to be really far away from my angle, and it might go off my page. So I try to make this pretty small. I would like for my first arc to be less than half the length of this ray here. So I'm going to open my compass about here, maybe even smaller. Let's go about there. And we are going to put the point on the vertex and draw our first arc, just like that. So you can see now I've got 2 new intersections. I've got one here and I've got one here. This is where we're going to put the point of our compass next. So we could choose either one of these to start with. I'm going to go from the bottom to the top. I'll put my compass on the next point. Then I will create an arc that falls somewhere in the middle of my angle. And I'll just repeat that step on the other point, like this. Perfect. So now I've created another intersection right here. And to construct that angle bisector, all I need to do is connect my vertex to that new point with a straight edge. So I'll line it up like this. And there we go. All right. Now we only have one more step to do, and that is to label this angle, showing that we have created 2 congruent angles. We bisected it. We cut it in half. So to do that, I need to put an arc here and an arc here. And we'd be done. So Question number 3 is going to be worth 4 points on your quiz. You will get 1 point for correctly starting with that first arc. You will get another point for correctly drawing the next 2 arcs here. You'll get another point for correctly drawing your bisector going through that intersection. And your last point will come from your proper labeling of the arcs to show that these are congruent angles. So there's your 4 points for number 3. Now let's move on to number 4 through 7 here. So for these problems, each one is worth 2 points. So I'm going to write 2 points on all of these real quick. And each of your points are going to come from these 2 things. You'll get 1 point for writing the correct equation. And you'll get another point for getting the correct value for x. So let's go through these together. Number 4, I've got 2 angles here, and these 2 adjacent angles are supplementary. Supplementary just means that they are going to add up to 180 degrees. So that means that this angle, the smaller one, plus this angle, that is 147 degrees. When I add them together, I'll get 180. So let's write that as an equation. X plus 12 plus 147 equals 180. All right. So there's my equation. Now I need to look and see, is there anything that I can combine? Do I have any like terms? And I do. Got 12 and 147. Neither of these numbers have variables, so I can combine them. So 12 plus 147, let's see, y'all know I'm not good at mental math. 12 plus 147, let's see, 159. So now I have x plus 159 equals 180. Now I'm going to use inverse operations here to get x by itself. I'll subtract 159 from both sides of my equation. 159s will cancel out, and I will be left with x equals 180 minus 159, which is 21. And then we circle our answer. Just like that. So there's number 4. All right. Let's look at number 5 now. So for number 5, we have 1, 2, 3 angles that are all sharing a point, angles around a point. So what's happening here is we have these 3 angles that create a circle. They are completing a full rotation. So that means that when I add all of these angles together, I'm going to get a measure of 360 degrees. So let's go ahead and set this equation up. Let's add them all together. I have x minus 116 plus 43 plus 287 equals 360. All right. So now I need to ask myself, do I have any like terms? I do. I've got a whole bunch of them. I have negative 116. I have 43. And I have 287. So I'm going to type this into my calculator to combine them. 287 plus 43 minus, because it's negative, minus 116. And that leaves me with 214 x plus 214 equals 360. So now I just need to get x by itself. So I'll use my inverse operations. Subtract 214 from both sides. And that is going to give me x equals 360 minus 214, 146. There we go. Let's look at number 6. So whenever I look at number 6, there's a few things that I am going to notice. First of all, I see these 2 arrows on my lines. This tells me that these lines are parallel. Then I have a third line that crosses through both of these parallel lines. And this creates our transversal. Now, whenever we have parallel lines and a transversal, we have some interesting angle relationships that we can look at. So for example, this angle here that measures 140 degrees and this angle here that is 5x degrees, we can call these corresponding angles because within their little groups of angles that fall on those lines, they're in the same location. They're both at the top right-hand side. So that tells us that these angles have the same measure. They're congruent. So instead of adding them together to find a measure and setting it equal to something else, I can actually set these equal to each other. So let's write that equation. 5x equals 140. Now to solve for x, I just need to do the opposite here. I have 5 times x. I'll divide by 5. Both sides. And 140 divided by 5 is 28. And that's my answer. All right. Now let's look at number 7. For number 7, I have 2 angles that are across from each other. These are called vertical angles. And we can tell just by looking at it, these angles are the same. Vertical angles are congruent to each other. We can also see that with these arcs. These arcs indicate congruence. It means they're the same. Just like in our corresponding angles, we had arcs that indicate congruence. So similarly to number 6, we are going to set these angles equal to each other to solve for x. So I'll write 10x plus 2 is equal to 152. Now we'll just solve like normal. I'm going to subtract 2 from both sides. That'll leave me with 10x over here is equal to 152 minus 2 is 150. Now I just need to divide by 10. And that will leave me with x equals 15. And that's our answer. So that is all the questions on page 2. Feel free to pause and ask questions if needed. I'm going to go ahead to the next page. So these questions here, numbers 8 through 11, are very similar to the questions on the previous page. They're also going to be worth 2 points apiece. And those points are going to come from the same things as the last page. You'll get 1 point for the correct equation. You'll get a second point for finding the correct value for x. All right, let's look at number 8. So in question number 8, I've got 2 angles that the values are given. And I've got 2 angles over here as well. But let's think about this. Are we going to need to use these 2 angles? This is extra information that we do not need. So we're just going to ignore them. Okay, let's focus on these. If I tilt my paper to the side, it might be a little more easy to notice that this is a 180-degree angle. So these are supplementary angles, which means if I add these together, I'm going to get 180. So let's do that and see if we can solve for x. 5x plus 1 plus 69 equals 180. Now I've got some like terms. Plus 1 and plus 69, those are going to add together to make 70. Bring down my 5x, bring down my equals, my 180. Now we're just going to solve like normal. Subtract 70 from both sides. Bring down my 5x equals 110. And then we're going to just divide by 5. And 110 divided by 5 is going to give me x equals 22. And that's my answer. There you go. Okay, let's look at number 9. Now, obviously, looks like I forgot to put a measure in this angle here. Looks like I forgot to do it for both of them. Okay, so here, let me give you something. This small angle here will be x degrees. And this large angle is going to be, let's see. I don't know. Let's play with it. Let's try 4. Okay, so I had to give you those. That's my bad, guys. I guess I missed that whenever I was making this. So number 9, we have another question exactly like on the previous page where we are solving for x with angles around a point. So let's go ahead and try to solve this. And I have a feeling I'm going to give you a decimal on accident. Maybe I should make this a different number, but we're already here. So I know that 4x plus x plus 116 is going to equal 360 degrees. So first, let's see if we've got like terms to combine. And in this case, we do. 4x and x. And when I add those together, I get 5x plus 116 equals 360. Now subtract 5x equals Let's try this on the calculator. 360 minus 116. X equals 244. And I see we are going to get a fraction. I'm sorry, guys. Let's do divide by 5 here. My 5s will cancel, and I will get x equals, let's see, 48.8. That's not too ugly of a decimal. That's not so bad. 48.8, and that is your answer. Perfect. So now we can go to the next one. Number 10. Again, I've got 2 parallel lines, and I can tell because I've got arrows on my lines that indicate these are parallel. So because we've got a third line here, we've got a transversal. Well, we've also got a transversal here. This is extra information. We don't really need it. It's just there to make it a little trickier. So I'm really just looking at these 2 angles, which I can tell they're in the same spot according to where they fall on those parallel lines. They're both in the middle left-hand side here. So that means they're corresponding angles, and we are going to set them equal to each other. So I'm going to write out 6x plus 4 equals 94. And all I got to do now is solve my equation, minus 4 on both sides. That's going to give me 6x equals 90. And now I just divide by 6 on both sides. And let's see, 90 divided by 6 is 15. So that means my x is 15. And I'll circle my answer. Now let's look at number 11. So number 11, we have got 1, 2, 3, 4, 5, 6 angles, and they are all sharing a point. So I could think to myself, well, all these angles around a point are going to add up to 360 degrees. However, I don't know this angle, or this angle. Well, I guess I do actually. Let's think about this. These are vertical angles, so technically this one would also be 89. This one would also be 3x plus 1. This one would also be 2x plus 20. But that's going to really complicate our answer. So this is extra information. We don't need it. Let's just look at the angles up here. I know that half of 360 is 180. And I also know that this right here is a straight line. That is going to measure 180 degrees when it's opening up like this. So I know that if I add these 3 angles together, I am going to get 180 degrees total. So let's just do that. 3x plus 1 plus 2x plus 20 plus 89 equals 180. Now, it doesn't matter what order you put these in. You could have put the 89 first or the 2x first. It doesn't matter, as long as you write them all and we combine them properly. So we got a lot of things going on here. We probably need to combine some like terms. I'm going to start with my x's. I have 3x and a 2x. If I put those together, I will get 5x. Then I've got 1, 20, and 89. So 89 plus 1 is 90. And then I'll just add 20 to that. So 90, 100, 110. And I'll just bring down my equal to 180. I wrote 100. That should be 110. I'm sorry, guys. Okay. So now we just need to solve for x and do the same steps we've been doing before. I'm going to subtract 110 from both sides. bring down my 5x. And I'm going to bring down that equals 180. I don't know if I already said that. I got interrupted for a moment, but I'm back. I had to pause the video. So here we are. Now I have 5 times x equals 180. We'll just divide by 5 on both sides, and that should give us our answer. X equals, let's find out, 180 divided by 5. 36. Circle our answer. So that is it for page 3. Now we'll move on to the 4th page. So here we are talking about midpoints. So on number 12, you are going to be finding the midpoint of the line segment that is on this graph below. So the first thing we need to do before we identify the midpoint is we need to talk about what these coordinates are, or our end points. So I'm going to do that by seeing where these points line up on the x and y axis. My top point is landing on x, it's 2. So I will write 2 in the first slot of my coordinate. And then it also lines up with y's 4. So there's one coordinate. Now let's check the other. This one lines up with -5 on the x-axis. And it also lines up with -3 on the y-axis. So now we have our coordinates, and we just need to plug these into the midpoint formula. So let's write out the midpoint formula. Midpoint So when we're looking for the midpoint of a line segment, especially when it's on a graph, we are actually looking for another coordinate to name the exact spot that falls in the middle of our segment. So all we're really doing is finding the average of our x values. I'm going to add x1 and x2 together, and I'll divide it by 2. And I'm just going to do the exact same thing with my y's. So let's plug in our values now. My x's are 2 and -5. So I'm going to put here 2 plus -5. That's the same thing as 2 minus 5 divided by 2. And for my y's, I have 4 and -3. 4 plus -3 is the same thing as 4 minus 3. So I'm going to write that. Also divided by 2. So now let's just solve these. 2 minus 5 should give me -3. And 4 minus 3 should give me 1. Now we just want to divide these numbers and get our coordinate. -3 divided by 2 is -1.5. And 1/2, or 1 divided by 2, is 0.5. So this is our midpoint. Now we need to label it on the graph. So first, let's see where -1.5 is. Looks like I go over -1 and half-ish. And then I'm just going to go up to 0.5 on the y-axis. So not up fully to 1, just about halfway. And look at that. That looks about to be right in the middle. So I know this answer is correct. And we don't want to make our graph too crowded, so I'm fine if you just draw the point. Just make sure you have your coordinates circled. So there is number 12. Let's try number 13. We're doing the exact same thing here. I'm going to put my x's and my y's here to help me keep track. So x and x, I've got 8 plus 3 divided by 2. And then I've got negative 9 plus 3 divided by 2. 8 plus 3, 8, 9, 10, 11. 11 over 2. And negative 9 plus 3, 9, 8, 7, 6. Negative 6 over 2. So now I'm just going to divide. 11 divided by 2 is 5.5. And negative 6 divided by 2 is negative 3. And that is my answer. So I'll circle it. Perfect. Now, these questions, number 12, this one is worth 3 points. You're going to get 1 point for plugging your values into the midpoint formula properly. Then you'll get another point for getting the correct coordinate. And finally, you'll get your last and third point from properly graphing that midpoint on your line segment. Then number 13 is worth 2 points total. You're going to get 1 point for plugging your coordinates in properly, and you'll get another point for getting the correct midpoint here. All right, last page. Number 14, number 15. Here we're doing something different. We're still working with graphs and coordinates, but instead of finding the midpoint, this time we're finding the distance between each pair of points. So let's start on number 14. First, I'm going to label my coordinates. So over here, I'm falling on x is 3, y is, negative 4, 3, negative 4. And on this point, I am falling at x is negative 1, y is negative 2. So let's remember what the distance formula is before we get too far in. I'm going to write it over here under 15. Distance formula. So to find the distance between 2 points, we start with big square root. Then I've got 2 sets of parentheses being squared and added together. In your first set of parentheses, we're going to take 2 minus x1. And in the second set of parentheses, we're going to do y2 minus y1. So let's use this formula for our number 14 here. I've got negative 1 for my x1, negative 2 for my y1, 3 for my x2, negative 4 for my y2. Now, it doesn't matter which coordinate gets named x1, y1, and x2, y2, as long as you make sure that we are plugging the proper ones into the formula. So we just need to make sure we're being consistent with the order we put them in. So let's start with our x's. x2 is 3, x1 is negative 1. So 3 minus negative 1, that's the same thing as 3 plus 1. Then I've got negative 4 minus negative 2. That is the same thing as, oh, I wrote it wrong. Sorry, guys. Negative 4 minus negative 2. Same thing as plus 2 here. And then all of that is going under a square root. So let's work one step further. 3 plus 1 is 4. I'm going to bring down that square, plus -4 plus 2 is -2. Bring down my square. And this is still under square root. Now I know 4 squared just means 4 times 4, which is 16, plus -2 squared just means -2 times -2, which is nope, not negative, +4. A negative times a negative makes a positive. So now I have 16 plus 4 under square root. 16 plus 4 is 20. And now I just need to figure out what the square root of 20 is. So to do that, we're going to use our calculators. And to find the square root button on our calculator, we need to use the button at the top left-hand corner that says second. So you'll notice that on the button here, it says x squared, and right above it in blue, you'll see a square root symbol. So to use any of the buttons that are not pushable, we need to hit second, hit our square root, and now you'll see a square root sign appearing on your screen. So we want to find the square root of 20. I'm just going to type in 20 and hit enter. And here is our answer, 4.47213595, and it might go on longer. I want you to round your answer to the second decimal point. So because after our second decimal point, we have a number that's smaller than 5, we've got 2, that means we don't need to round up. Our answer is going to be 4.47. So I'm going to write here 4.47, and I'm going to circle it, and that is my answer. So now let's do number 15. Same exact process, just with different numbers. So x1, y1, x2, y2, and let's plug it in. -4 minus 3 squared plus 0 minus 8 squared, all under square root. -4 minus 3, that's the same thing as -4 plus -3, and that's going to give us -7 squared, plus 0 minus 8 is -8 squared. Now let's do our squares. -7 times -7 is +49, plus -8 times -8 is 64. Now let's add 49 and 64 together to get our answer. 49 plus 64 equals 113. Okay, so now we have the square root of 113. So we're going to use the square root button again to solve that. Second square root, 113. And I got 10.63. 10.63. And that's my answer, so I will circle it. All right. Number 14 is worth 2 points. Those points are going to come from using the proper parts of our coordinates in the formula. And the second point is going to come from getting the correct answer. And same thing on number 15, also worth 2 points. All right, let's look at our bonus question. So we did not cover this. That's why it's bonus. For your bonus question, you can earn up to a possible 2 bonus points. So let's see what it says. It says, draw a picture that represents the situation. Okay, so I know I need to draw a picture. Let's see what the situation